Welcome back. In this video, we're going to introduce you to one concept involved with programming in simulations. I have a little physics chem background, and sometimes I like to tinker and program in something that represents the real world. And the real world changes over time. And when you're coding stuff that changes over time, there's a little trick that you might have to do. So just to introduce you to the ideas, what I'm going to do here is I'm going to pretend that these dots, whatever they are going to follow a little rule. And as I hit the button over and over and over, I want them to progress through time following my rule. And my rule is going to be this. If you are a white square, you will turn the square to the right of you white. So when I hit the button, what I want to see is something like this. Every white square turns a square to the right of it white. Now you can imagine if I was to hit the buttons fast, maybe that's a little simulation for sideways rain, or I don't know, laser beams, shooting off to the right. So how can we do something like that with our grid? Now, I know you probably have an idea how you might do it. I'm going to show you the typical student solution, and the typical student solution does this. And that's obviously not right. I want this to happen step by step over time, right? Every time I hit the button. So let's go examine this a little more detail to see exactly what we mean. So remember the rule. Every square that's white turns the square to its right white. Okay, here we go. So this is the typical student solution, what they want to key in. Okay, it's probably what I would have done back in grade 11, 12 too. So you'll see here I just cycle through the grid. You will notice that I'm not starting at 0 and I'm not going right to the edge. I'm trying to save time here and avoid any index out of bounds errors, because you see here in my code I have a +1. So if I go right to the edge, I'm going to be out of bounds, and I didn't want to put the if statements here to check that. So I'm just going to sort of put a little buffer zone around the outer border to protect me from my out of bounds errors. So you'll see what I do. I basically say, hey, grid, if whatever square I'm on is white, a value of 1, then take the square to the right of me and turn it white. Now that seems to make so much sense. But here's the problem that ends up happening. And I'll just run the simulation to show you. Let's say that's my square that's white. When I hit the button, it's going to scan, black, 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 black. It eventually gets to my white square and goes, oh, I'm white. Turn the square to the right of me white. So it does. But then you got to remember, the loop we're in now moves on from this square to that square. And it asks, if I'm white, well, it wasn't white before, but it is white now. So yeah, I'm white. Turn the square to the right of me white. So it turns the square to the right of it white. Then the loop continues. Move over a square. Hey, if that square is white, turn the next square white. Turns it white. So you see the problem here. In my one button press, since I'm affecting a square that's going to be involved a little later on in my loop, this just ends up streaming all the way to the right. And that's why I'm getting that problem of this. Okay, so all my white squares just, bam, go to the right. Now, what's the fix for this? Well, the fix is we can't just use one grid or one matrix. What I have to do is create a temporary matrix. So here's the solution. And this solution pops up in a lot of different problems for grids and matrices that change over time. What I do is I do button 10. Now button 10 is the good solution. You're going to see what I do here. I make a temporary array. And this temporary array, exactly the same size as the grid, okay, is going to be like a clone of it. And all I do is I go through the matrix like before. And if the grid's value I'm on is a 1, then I turn temp of the exact same square to 1. So this will basically make temp match that square's white, and tell temp to change the square to the right of it to 1 as well. The nice thing here is I'm changing the square to the right of me inside of temp. But this if statement here is always referring to grid, our original case that we want to be checking against, right? And so this way, these squares that I'm turning white to the right of me are all inside of temp, aren't going to affect as I go through my original grid two-dimensional array. And that's really the solution. Once you've gone through every square, all the squares that used to be white are still white, and all the squares to the right of those squares are also white. Leaves us with only one short step to do. When you're all done, this temporary array is sitting there, all perfectly sort of drawn. You set your grid variable to equal the memory address of the temp grid. And basically, grid is now that temporary matrix. And so you've updated your grid. And then, of course, do a draw so you see the results. And that's it. That's sort of a quick, easy solution to this, so that the square before you doesn't affect your decisions in whether to change a square black or white. Now, this kind of solution is actually used in a couple of different things you've probably seen if you've ever used photo programs like Rotate or Contrast or Flip and stuff. There's a lot of things you might want to do, but if you do it to the neighboring squares, that's going to affect what you do a millisecond later. And so what you're always usually doing is you have a temp grid, and that's where you actually plug the changes, and then when you're finished, set your grid to equal that temp grid. There's going to be a problem or two to pick from to try to practice this. They're good ones. If you decide to do the rotate grid question, that's a great one that students have always warmed their minds up with and had a good time trying to solve. But there's a few others there you can pick from, right? Just to practice this idea of using a temporary matrix. Thanks for watching.